I know we're running a little late, so I'm going to try to get through this quickly, but I had hoped to break this down into 4 parts. First, a few historical grace notes about the curtain wall, some things that some of you may not be aware of. Then I'd like to just walk you through our evaluation of the existing condition of the curtain wall, which we undertook in 2001, with respect to the potential for actually restoring the curtain wall. The criteria for those evaluations are inspection methodologies, our findings and conclusions, and thirdly, the decisions taken on that study and the design work that we began in 2006, the design, performance criteria, the selection of new materials, and so forth. And finally, show you some of the current work that's underway. The UN Secretariat is actually the first all-glass curtain wall skyscraper in the US and arguably the world. The Equitable building did come on a few years later, but it is not a curtain wall. It's an infill glass window wall with aluminum cladding tightly clad over a concrete structure. The Lieber House followed the Secretariat by a year. There are many interesting aspects to the design, a few lesser known and often represented. But one really interesting thing about the wall is it is actually a unitized curtain wall. For some of you, maybe a surprise, it's often referred to as a stick system. It sort of functions as a stick system, but it was actually prefabricated into units, as you can see here. And on the next slide, especially, you can see one of the units right up here. This is pointer isn't working. Okay. On the very upper left corner, one of the units is going in. These are units without glazing sash. These are empty frames, if you will. And here you can see a sketch of the original mullion, which was a composite of steel and aluminum. But basically, you're seeing here the left and right side of the unit coming together as the mullion. And these empty frames were filled with windows, double hung windows, rather standard. And here you can see the building going up. The upper part are the empty units, and down below you can see with the little reflections the glazing that's going in. Now, many of you are familiar with the design committee's struggles with the curtain wall design. There were lots of debate, lots of confrontation, mostly between Le Corbusier and Wally Harrison. Corb, of course, was arguing for the exterior brise-soleil and presented a lot of support for that. This is one of his sketches attached to a letter sent to the committee. And Wally Harrison was really more interested in championing the latest technologies, the new glasses being available, and so forth. But they both spent a lot of time analyzing the Secretariat's orientation, the energy impacts on this, and so forth. And Sisk & Hennessy, actually, Keith's firm was involved in the early design in 1947, and they prepared this analysis here of different glazing and shading options from, I'm sorry, the pointer's not working, but from the upper left, you can see ordinary glass and then heat-absorbing green glass, then insulating glass and heat-absorbing insulating glass, each with different kind of shading treatments and so forth. And then as a gesture to the Corbusier, exterior shades were considered louvers and so forth. Now, also as a compromise gesture, it was agreed that they were going to put the brise-soleil on the inside of the glass, the new Lavallure Venetian blinds. And, let's see, there we go. And the building was to be the new Libby Owens Ford thermopane insulating glass into the double hung window sashes. The dirty little secret is They realized only too late that the insulating glass was too heavy for the sashes. So what had originally been this agreement to use this high-performance insulating glass had to be scrapped at the last minute. The actual glass is monolithic green glass. Whoops. There we go. Okay, so on the right is the actual vision glass. It's a historical sample from the UN archives of the PPG Solex, still available today, although the color is slightly different today. And in the spandrel area is a wired green glass Aclo. So of course, this is why the building was having such problems. It was so uncomfortable. It really, the heat absorbent glass was really not functioning as it was intended. And right away, only a few years after it was complete, they began putting reflective films on the glass. So the interesting thing is that the original appearance of the building, none of us really know what it is, because they've had the films on there almost since day one. And the original glass, you can see here, this photograph is very transparent. The idea, transparency, was metaphorically part of the original design. And of course, if any of you walk down 43rd Street today to come to this affair, you can see what the building looks like now with the reflective film on it. So we began our evaluation back in 2001, really in the archives of the UN, a fantastic collection of information on the curtain wall, of course all the other building systems, totally unprecedented because they didn't throw anything away. Normally on buildings like this where we're working on renovation, they don't have any drawings, architecture, nothing is available, but here we have absolutely everything. So it was really wonderful. And a wonderful set of drawings to evaluate. So we really went through the drawings, all the correspondence, all the construction history, the memos and everything else to really get a full understanding of the wall, and developed some criteria for evaluation of the skin in this initial study. And we wanted to understand how pressure worked through the wall. Of course, it's not pressure equalized, but that is the goal. How the wall would respond to building movements, how it would respond to building deflections, floor deflections, and problems with corrosion and dissimilar metals. It's clearly a big problem with the steel nested in the aluminum mullion that we have. Let's see, just click it, there we go. Analyzing the structure of the curtain wall and the anchorage with respect to the wind loads, not only the original wind loads, which were low, but what current wind loads, its thermal performance. We did a lot of analysis. This is one early little sketch to understand how the wall performed thermally, but also to understand where condensation was occurring within the wall, so we would know later where to go and look for inspecting for problems. Air infiltration, it's pretty clear analyzing the drawings that there was big problems with air infiltration, as you can see from this sketch. And of course, water filtration was a big problem. And there's plenty of evidence of that. And in fact, this, the upper right, being held in hand here is a little patch plate. Months after the wall was finished in 1950, it was leaking. They came back and had all kinds of little doodads, little patch plates and this and that. The whole facade was just encrusted with these little covers to try to close all the holes. When we first started, the UN, we were all convinced that we were just going to restore the wall. Maybe, do a little of this, a little of that, and that was it. So the idea of taking the whole thing apart and figuring out what's wrong was really not, we weren't permitted to do that. So we had to go about our investigation looking for clues that we knew we would find, or hoped we would find, or thought we would find, having gone through the study of the drawings, with non-invasive techniques. So we did a lot of boroscopic investigation, drilling holes, you're looking into the holes inside the curtain wall with the borescope. And we did discover that the steel in the mullions was severely rusting on a large percentage of the wall. And in fact, we learned how to find this because you could see the aluminum bulging a little bit. So we could do all these inspections from the inside just looking out through the window, because the mullion is an exoskeletal type of mullion on the UN Secretariat curtain wall. So when the steel was rusting, steel expands to 6 times its dimension, and it was actually bulging the aluminum out. So we could see where to stick the borescope in and confirm indeed that we had a problem. So once the borescopic investigations confirmed that indeed we did have some serious problems that were unforeseen, the UN permitted us then to go into a more invasive inspection. So we developed a statistical model for how much wall we would have to inspect to get a 99.9% confidence level in our findings, so that we could decide how to proceed. And this is one of the diagrams for where we dropped the swing stage off the sides to do these inspections from the outside, take the wall apart. We took all the spandrel glass apart to check these anchors, and we had determined, of course, by statistical analysis what percentage of anchors we would have to inspect in order to have confidence that we were really getting a sample that was representative of the whole building. And we ended up having to check about 1,472 anchors to get that confidence. So we began the inspections, and here you can see they're removing some spandrel glass. Our inspections, of course, included division glass, which pretty well foregone conclusion that it was not salvageable. Same thing with the spandrel glass. As you can see the diagram on the right, the lower lighter color is what at the time was the only remaining glass. That spandrels have been replaced with all kinds of glass over the years, because this wire glass was not able to take film shock in those days. So a lot of glass broke just because when the sun would come up on a bitter cold day in the morning, the glass couldn't absorb that thermal shock and it would crack. So a lot of it was replaced, especially in the east elevation. And you can see the degraded condition of the spandrel areas, and of course the degraded conditions resulting from water infiltration. And the diagram on the lower right is some of the little added components, and the arrows of the upper right pointing to some of these added patch plates and fittings that were smeared on the outside of the wall to attempt to keep the water out. And the aluminum itself, of course, this was actually, we were able to determine it was really only a class 2 coating. It was a half-hour anodized coating on the aluminum, and there was a black component that was black anodized. Not really the best coating for resisting atmospheric pollutants, and so the aluminum really was pretty severely corroded. It would have been really impossible to salvage any of the aluminum architecturally. And of course, there's just every manner of caulk and sealant. You can imagine a whole generational study of what was available. And insulation, absolutely no insulation, believe it or not. There's a little bit of insulation on the inside of the knee wall. That's a yellow concrete block wall there. Happens to be asbestos, but it's intact. And but just above there, you can see a big gap between the top of the concrete block and the curtain wall. There's air, just lots of air, cold migration and so forth coming through there. And below the slab also, as you can see. And we did a brief analysis working with Keith and Assistant Hennessy of what with respect to the U-value shading coefficients or solar heat coefficients and air filtration, what the code might require on the very left. The next two bars, the existing conditions at the east and west elevations, and what a repair option might result in, not too good, and next what a restoration option might result in. And finally, it was becoming pretty compelling that if we were to meet any kind of energy code conformance at all, that replacement will really have to be seriously considered. And structural integrity is a very big thing we're looking for, checking all the anchors, and of course, as I mentioned before, the boroscopic investigations, mostly at the mullions, but the anchors proved to be the real surprise and pretty scary. A lot of the anchors were really rusted out, and not so much from water infiltration, but because the insulation was so sketchy, there's a lot of condensation inside behind the system. Oops. My screen went out. It's up there. We did a serious structural analysis on some of the anchors, and indeed we had to determine that we had classified them different corrosion levels, 1, 2, and 3, 3 being the worst, but that indeed over 50% of the anchors were corrosion level 2 and 3, which would not have been able to withstand combined wind dead loads in a severe wind event. Now, that wasn't cause to panic, because we did another analysis to see how the wall knit together, and that actually we did have a huge hurricane. Would the wall come off? No, we decided it would not, because there was enough knitting together of units because of this unitized construction that actually we could prove to the UN that the wall was actually safe. It might come loose a little bit, it wasn't going to go flying off the building. So after this evaluation, we, together with CMP and the other consultants, we put together this sort of matrix for what our options were. Of course, we were originally hoping just to do a few little repairs and possibly some restoration, and the final option was, if we couldn't do that, then to replace the wall in kind to try to match it as closely as possible. So we came up with this. It was a very complex analysis with all these criteria, and this was a little matrix to try to present it graphically. But you can see, obviously, opportunity was a big one. Here's a once-in-a-generation chance, as Michael mentioned, to do something, get another 50 or even 100 years out of the facade. A big opportunity, also for longevity, with same issues. For performance, of course, all the performance criteria were evaluated. For security, and historic preservation was high on the list. And, of course, for sustainable design. Now, the 4 categories, the Secretariat itself is highlighted in red. Option number 1 was repair. Option number 2 was restore. Option number 3 was replace in kind. And we actually did, at the UN request, go into a 4th option, which was a more high-tech, modern replacement. It was actually a double-skin facade, which you'll see later we decided for appearance reasons and historical preservation reasons was really not appropriate, but we did go through the exercise. And finally, having decided that replacement was going to be necessary, especially in consideration of safety and security requirements, we developed a preliminary design with the main intent was to preserve the historical profiles to the greatest extent possible. And these were some of the target performance criteria that we were hoping to achieve. Of course, we would have to conform to new wind loads with the current codes. U values increased, at least 4 times better. Shading coefficient 3 times better. Air filtration 5 times better, but actually in the performance mock-up test, the actual air filtration rate was 0.02, so even 3 times better than that. And of course, no water filtration allowed or condensation. And of course, the wall had to provide a secure environment for the future. So I'm skipping through a little bit the whole bid process, but we felt that we had bidders from all around the world, curtain wall companies, and we made a presentation to all of them as a team, and we wanted them all to understand what our goals were, especially for historical preservation. So this is part of that little talk, to show them in here in dark gray the existing profiles, and in the line drawing the new profiles. And because of the location of the structure and because of the additional structure required to meet these new performance criteria, we did have to move the wall out a few inches, and that's what this is demonstrating. But you can see the profiles are very, very close. This was a huge challenge. You'll see it a little bit later, some of the lines. Here's the end wall condition of the stone, the sill condition, and the head condition holding to those profiles. We felt it was very important to get all the bidders. This was a pre-bid conference where this presentation was made. They understand what our priorities were, and the historical profiles was a very serious issue. And the curtain wall was awarded to this company, Benson Industries, out of Portland, Oregon. They have factories also in Korea and Mexico, where the wall is being made. And you can see how complex these mullions became because of all the considerations, not only the normal ones, but also for blast resistance. And in the spandrel areas, we have over on the right there, in addition to about as much insulation as we could pack in there, we have insulating glass. And that proved to be a big challenge in terms of the historical matching of the appearance of the glass, because obviously insulating glass has got many more surfaces, so it becomes much more reflective. And we were really trying to match the monolithic appearance of the spandrel glass. We'll get into that in a moment. And here's the stack joint sections, stack joint between units at the sill, and the head condition. These are the final profiles. And significant hardening, as you can see there at the slab edge. The intermediate style, we had to give up the operable windows. We did some tests on whether you could see the, obviously a double hung window, the two lights of glass are in a different plane. We did a lot of studies and tests to demonstrate that actually the original design was to have the glass in different planes, and we just felt with difficulties in the design that you could almost not tell that the glass was in different planes. So everybody was convinced that it was viable to put the glass that replicated the two double hung window sashes in the same plane. Now, the glass, of course, was a huge issue here. And this, you've seen this shot a couple times already, and this is the shot with the reflective film on the west elevation. And since the original, we were very concerned that all the new glass that we're considering would match the original glass, but we couldn't hold it up against the building because we no longer have the original building. So this is one of the slides to the contractors, again showing the reflective glass versus on the right the more transparent original glass. So what we did is we took a photograph of the building. It's actually from April 10th, 2007. And we took a photograph at 2:30 in the afternoon and at 6:30 in the afternoon of the existing building. And then we, using the spectral data of the filmed glass and the spectral data we calculated from the original glass, we were able to create in the computer what the original building should have looked like in the middle. So on the left we have the current glass, in the middle the original glass, and then we tested it against all kinds of glazing solutions, just as Siska and Hennessy had tested it back in 1947. with double glazing, triple glazing, blinds, where the blinds were, how far back they were, and of course with the double skin facade. And we were able to convince ourselves that we were moving in the right direction with some of the glass choices. And here's the 630 shot, the current condition, and then what the original might have looked at and what our proposed insulating glass would look at. A pretty close match. Of course, if we'd had the time and money, we would have done this with other different sky dome conditions, cloudy days, morning lights, you know, and so on and so forth. But I think this exercise, we were pretty convinced we were on the right track with what we were trying to do. And so this is just, we'll just go through this. You can see some of the changes. They're subtle, but we'll try to do them quickly. And finally, that was the double skin facade. And then in the evening, at 6:30, the original, and with different triple glazing, and this is the double glazing, triple glazing, this was the double skin facade, which you can see really much too reflective, very, very big departure. So once we define the glasses that we could consider might be appropriate to try to match the original vision glass, we went through a whole sampling study, and we had manufacturers, glass companies all around the world preparing samples, special coatings and things to try to match our criteria. And at the end, we narrowed it down somewhat, and we had a big session up on the roof of the Dr. Hammarskjöld Library, putting these samples out, because as you know, you really can't look at a sample in a conference room. You have to get it outside. We're looking at different daylightings, different sky dome conditions, and so forth. And we got it narrowed down pretty well, and then got the whole team out there and made the final selection, which we then, well, there's some of you can see some of the subtle variations, some of which some of these low-E coatings, as you probably know, high-performance low-E coatings, have strange polarizing color shifts depending on the sky dome color, different times of day, morning or afternoon, and we wanted to be sure that we wouldn't get any surprises from some of these effects. So that's why we did this very careful study. We were up on the roof many, many days in different kinds of conditions. And you can see here some of the differences. These glasses, these products were all deemed to be exactly identical inside in a conference room. Look how different they are. Another shot, different was for... And then we went to a full-size visual mock-up right on site, and a little chamber with some different, the final 3 glass options in there, the vision glass, and made a selection there. And here's a close-up of that. We were able to also, of course, looking from the inside out, as well as we wanted to understand what these different manufacturers could offer in terms of glass flatness, because of course the glass is all heat treated, so it's going to have roller wave distortion and other issues. We wanted to be sure that all of that was going to be worked out. And then, and then we went to do a final test on the spandrel glass on the actual performance mock-up. You can see the slide on the left. The default spandrel glass on the left is much, much too reflective. And we realized that on the performance mock-up because you could see it up high if you get sky reflected in it. The visual mock-up on the campus, the spandrel glass was too low. You couldn't pick this problem up. So then we experimented on the right with changing out different glasses. And fascinating, what happened is, you can see the spandrel area is right there, that the narrower glass. The one on the left is actually a monolithic piece of glass that closely matches the original. And the 2 on the right are the ones that we finally got to match. And they are insulating glass, and we were able to do that by making the inner light gray with a special coating to cut the reflectivity down. So kind of a counterintuitive solution, but it seems to work. And we were also very interested in the aluminum. We're running out of time. Okay. So The aluminum, the original aluminum had a very funny textured finish. They were trying to match stainless steel. We were concerned it was not a friendly or easily maintained finish, but we were trying to match it. And we were working with the Korean fabricators and finishers to achieve this. We went through a lot of sample changes and testing and so forth. And finally, we got a good finish. We would think it's a great match. It will be easy to clean. We actually have 94 extrusions on the project. Isn't that amazing? 94 separate custom extrusions. And here's one of our dies, and here's a worker actually working on the dies. That's how we achieve this finish that matches the original finish. Hand working the dies. And this is in Korea. There's some of our extrusions. And some of our units being fabricated in Mexico. These are fabricated for the performance mock-up. Here's the performance mock-up out in California. And we were testing, of course, for thermal condensation resistance, structural performance. Here you can see the pressure test. Usually the glass is bulging in due to the chamber pressure. And we did, of course, air infiltration, water infiltration. This is a setup for the dynamic water filtration test with a hose rack and an airplane engine, and the actual test. And finally, we're over. We got through it, Carol. So what's interesting is the irony. We will have a new curtain wall that will be closer in appearance to the original, we believe, than the wall that we have out there now. And, interestingly, closer to Harrison's original design intent because we will have insulated glass. That's it. Thank you.